Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super. And today's incident we're going to focus is on Azure OpenAI. This was an incident that occurred in our East-US region. It impacted customers for approximately 9 hours on the 9th of April. The interesting piece is that it was Azure OpenAI that had a dependency on API management, which you might hear us refer to as APIM. And so both of these actors are key in this story today.
Right, so to talk us through the incident and our learnings, I'd love to introduce the engineering leaders joining us on our panel today. We have Chris Basselglou, Vice President of Azure OpenAI Engineering. Thanks for joining us, Chris. And we've got Galen Iliev, our Partner Software Manager for Azure API Manager, both key kind of characters in the story here.
Super. So as we start, Chris, before we get into the actual incident on what occurred that day, could you walk us through how Azure OpenAI is architected? What usually should happen when you see these kind of things? How should APIM respond? What's the typical response that we should have seen?
Sure. When we first started designing Azure OpenAI Service, one of the main design principles was that we would use all Azure native components just as a third-party Azure customer would build their own service. So we use all of the native Azure components, and we start with APIM. APIM is where we host the customer visible API for Azure OpenAI. And in APIM, we do authentication, we do some high-level routing, we do some rate limiting, and we also apply internal headers onto the request as the request goes out of APIM and down into the backend. In the backend is where we have our GPU, our code, and the OpenAI models and all of the computation. So as a request comes through, it goes through APIM, it gets routed to the right place, additional headers get on, it gets authenticated, and then gets sent to the backend for processing, and then returns back through APIM back to the customer, the response.
Got it. So it sounds like a pretty critical dependency taken on API Manager here. So that's good to understand kind of how it works, or how it all worked before the incident. Chris, what happened? Let's fast forward to the 9th of April. What went wrong as this outage kicked off?
Yes, since we brought Azure OpenAI out to the public, the traffic has grown dramatically. It's been a very successful service, and in particular, we have an APIM stamp across one APIM stamp per region. One of our critical customers happens to be an internal customer, GitHub. They're very successful service. Traffic is increasing. And on that day in April, the traffic got to a certain extent where we started to hit some limits in APIM. In particular, HTTP2 requests were being used, and the latencies started to get high enough that the GitHub Copilot application was doing some cancellations. As the latency got too high, they were canceling the requests. That caused even additional load, and the latencies hit a critical point to the such that the alerts fired, and we had to take action.
So, super. And Galen, if I can turn my attention to you, this is really interesting. So as traffic is building up in East US, GitHub are a contributing factor because of their success. How did APIM, did they scale out? Are they able to handle it? What happened with APIM, and kind of can you walk us through the role that APIM played here and where you guys suffered or struggled?
Yeah, absolutely. As Chris described, APIM is the entry point to the system, and all the customer requests, including big copilots in the company, goes through APIM. And those copilots have different requirements. As you know, large language models can take some time to respond. Those requests are staying in the system, and for some some copilots, the latency is very critical. So measuring the time to response is very critical for the experience. As those requests are coming up and building, we're trying to optimize the request, the connection load balancing, the request time that's spent in the system, and helping one of those copilots to scale better. So prior the incident, we applied set of settings across different regions. Probably you know about safe deployment practices that we're using to make sure the impact is not is contained. And we were able to successfully apply those settings in different regions before that without any impact to the customers. Coming to East US though, the East US is a very popular region, very highly loaded region. And what we haven't realized that the East US is leading to applying those configurations to optimize the connections. There was a set of settings that are also applied in the system that limited the amount of memory used in API management. So the machines were there, the scale was there, but as a broader effort that we had before, memory was limited in the on those machines, which led to increased latency in the requests.
Got it. How frustrating for you to be like, no, we've got all the right things turned on, but we weren't able to use all the memory as designed. Chris, we're hearing from API Manager here. Was there anything that OpenAI could do during the incident? Are there levers that you can pull to help mitigate, or it's such a critical dependency that really API Manager needs to be able to scale to the traffic and your hands are tied?
I think during the incident, the main thing that we could do from the AOAI, Azure OpenAI point of view was first narrow down where the latencies were coming from. You know, at the beginning, of course, we didn't know, was it coming from APIM? Was it coming from some issue in the back end, in the engine, from some, maybe from Cosmos DB or somewhere else. So the initial things that we did was the triage, figure out where the latencies were coming from and why. So, we noticed, okay, the majority of the traffic was coming from our one particular large customer in this particular region at this particular time. And it was related to the HTTP2 traffic with the cancellations, and the number of cancellations were getting higher, and the number of reports from this particular customer were also increasing. So first was triage. Then we tried to do what we could on the back end. We tried, scaling out like number of backend pods. We tried, increasing bandwidth, through our networking. We tried all those things, but then we were able to decide that no, this needs to be resolved, in the HTTP2 settings within APIM, and that's when the APIM team started to try to roll out some changes in configuration to optimize things.
Super. And Gavin, and thanks, Chris. So it sounds like Azure OpenAI pulling levers, but there comes to a point where you run into an issue and you call in APIM. APIM comes along, and now when you try to start assisting and mitigating this issue that was predominantly impacting Azure OpenAI, you pulled some levers, you made some changes, but some of them weren't as simple as you thought they were, and you ran into a few snags. Could you walk us through that, please?
Yeah, unfortunately, the mitigation didn't work as expected and as we codified. What we have as a part of rollout procedures is if there is any impact during making changes, there is automatic rollback that happens. The rollback started to be exercised. The first thing, even before fully understanding what was the root cause, we identified there was this change that was rolling out. The first thing is get system to the last known good state. So the system was started the rollback, and the rollback showed initial signs of improvements in the latency. So that was a kind of a false confidence that we saw in the telemetry and the operating charts that we have. So we proceeded with that. The rollout itself doesn't apply everything in the cluster at a single shot. It goes step by step, what we call upgrade domains, and that's what takes time. So by the time it advances enough, we realize the decrease in the latency is not going all the way down to the previous baseline that we had. and essentially the mitigation that we're applying is not going to lead us to fully mitigate the incident. So that was what led to the prolonging of the mitigation. So we started looking what was missed in those cases, and we saw that applying those settings for the memory limits was not included into the rollback procedure. So at that point, it was identified as a root cause. We again started another rollback, which ultimately mitigated the incident and brought the latency down to the baseline levels.
Got it. That's helpful. You might have to put $1 in the root cause jar. We try to avoid saying root cause here. Obviously, our systems fail in complex ways, and there are multiple contributing factors. That's a great point. So I'm glad we eventually figured out, that part of it, and we could make that change here. I'd love to pivot some of our learnings and repair items here. Chris, I know the post-incident review talked about some additional monitoring. I thought we kind of caught the issue relatively early, and it just took time to mitigate it. Well, what additional monitoring do you think is going to set us up for even more success?
Yeah, I think traditionally with Azure OpenAI, given the SLA promises that we make to our customers, latency is not as high of a factor as what we provide our SLA on as other factors like errors in the return codes and things like that. So our monitoring kind of did catch increased latency, but it didn't necessarily alert us right away to a full-blown high severity, high priority incident, because that's not traditionally part of our SLA. With this particular internal customer with GitHub, they are very sensitive to latency. It's GitHub Copilot, as people are typing their code and it's doing a code completions return. That needs to happen very fast on the order as people typing in their code. And so our customer in this case noticed it, perceived it as a much higher priority issue for them than we were noticing it for ourselves. But we did catch it in our internal monitors. We just didn't raise it as high of a priority as we could have. So one of the things that we've changed as part of our repair item is treating latency more as a first-class citizen, as part of our internal SLAs to our 1P users, and eventually also to our 3P users as well.
It's really interesting. I get interested speaking to our SREs about the philosophy of monitoring, because our default seems to be like add more and more, but it becomes noisier and noisier. And if we don't have great service level indicators, then creating runbooks and automation is tricky. So I know when we say monitoring, it doesn't necessarily mean just add more. It means it's fine tuning. It's making sure we have the right criteria and right response, which is interesting. Chris, one of the other areas that was interesting is that during an incident, typically they're unforeseen. And so typically you are pulling multiple levers. You walked us through all the steps that you were trying to do to mitigate during. And I think one of the repair items which was interesting is you're going to consolidate all of those potential levers into simplicity, so that when things happen again, you don't have 18 levers to pull. You have 1 or 2 that can take action. Can you walk us through some of that, if I understood that correctly from the repair items?
Yeah, I mean, I think we are adding essentially automation to allow us to, as you kind of mentioned, pull some of these levers, adjust certain parameters, on the back end, reboot machines if needed, and so on. So that can be done in a much more automated way, much earlier, and can be automated in a way such that even before a DRI gets called into a ticket, that certain things can be tried and ruled out, or actually self-healed as quickly as possible.
Cool. That's great to hear. I'll help to translate DRI. We use as a directly responsible individual for our on-call engineers. So it sounds like you're building more of a single pane of glass to help kind of their person to be more empowered. That sounds really good. Quick question. I'm not sure if it's a question for you, or maybe I'll need to involve Galen here. But Chris, I was really surprised to learn that you all in OpenAI use one Azure API manager per region. What is that? That's an intentional design decision. Is that something? Would you rather scale that up or scale that out? Like that surprised me to hear.
We all talk, and then I'll let Galen talk. So as I mentioned, when we first started with Azure OpenAI, it was a fast-growing service, and the traffic kind of increased over time. We started out with one stamp of APIM per region, and as the traffic grew, we scaled APIM up in partnership with APIM team, and that involved moving from the existing VM type to better VM types, more powerful VM types. It involved changing databases, number of shards and other things. But then eventually in this particular incident, we couldn't scale up anymore, and so then Galen, maybe you want to talk about.
Usually the architecture that the customers have is having one API per region. That's what it starts from, and having multiple region from our perspective look like the right decision, because secondary region provides a failover opportunity. As the grow with Azure OpenAI and quickly ramping number of calls, number of customers per region, which is amazing problem to have. That accumulated many critical customers in a single region, and as the teams were working to scale out and scale up was the fastest mitigation for all the incoming traffic and onboarding new customers. So now, as part of the repair items, we have that part to split up API management services and provide better horizontal scale. Horizontal scale is what is always recommended, because that's essentially built out to handle more traffic and reduce the blast radius as well.
Again, I'm really interested in this. I'm hoping you can help me understand. When I think of when I go through the literature, as I understand Azure, typically when services hit thresholds, they scale out. It's just automatic. It's magic. It's part of the cloud, particularly with our PaaS services. Is APIM able to do that? Like, surely if you're hitting some sort of threshold, you just click a button, automation happens, scale out happens. Is it?
Yeah.
Why can't that happen?
It is possible to scale, and as demonstrated in this case, Azure OpenAI was able to scale API management quite a lot. Stretch it, I might say. We haven't provided infinite scaling for API management, mostly because it depends highly on the customer architecture. And in the secure environment, customers are very sensitive about IP addresses, outbound IP addresses, virtual network sizes, and where the traffic to the microservice is coming from. So there is a lot of other securing components in the overall customer topology, which makes it hard for API management side to scale infinitely. It is possible, again, to keep adding more machines, keep adding more outbound IP addresses, but hitting limits like how many IP addresses are allowed listed in the customer network, how big is the subnet size, is APM able to get a hold of the IP address to handle traffic within the customer network. All those are questions that we cannot make ourselves, and we rely on the customer who is designing the system, the system to do. And the other aspect is we do have big customers who, again, for external customers as well, for which API management is a critical component. And when they approach us to scale more, the advice that we give them is to think about the failover. If concentrating so much important traffic in a single place, thinking about failover, thinking about the blast radius. As we have multiple teams here working on a single system, one of the principles is no single team should be able to bring down the system with a single action, right? So basically doing that partitioning, we advise that customers to do as well. So that's why we don't provide out of the box to have infinite scaling. Trying to help customers that way too.
That's great to understand. So it's absolutely possible. It's just a little more complicated than the magic that Sammy was expecting. Yeah. That's cool. Thank you for that. Chris, I'm interested. We've been talking a lot about how we improve our own resilience here. We've got learnings from the Azure OpenAI side and the API Manager side. I'm interested if there are learnings for customers that are using Azure OpenAI. In these sessions, we often say outages teach us something really interesting, and hopefully Microsoft learns from them and improves. But it's also obviously a shared responsibility model when customers are using our Lego pieces to architect their own system. So is there anything that customers could have done to be more resilient to these kinds of failures? Everything we're talking about here was limited to East US. That was just one of the many regions that Azure OpenAI provides. I was reading in the post-incident review about geo-replication. So it sounds like it's possible for customers to be able to kind of load balance across regions. Is that hard? Is that complicated? Is that expensive? Do many people do it? What's the recommendation?
Yeah, I think, as you mentioned, Azure OpenAI is a multi-regional service. I think we have close to now 30 regions across the world with the Azure OpenAI service. And in Azure OpenAI service, we offer many tiers. We offer standard service, which has various flavors. There's a regional flavor, which you choose a region and all the traffic stays in that particular region. There's a data zone standard, which within a kind of legal data zone where there's data sovereignty, there can be routing within the data zone across regions within the data zone. And then there's a global offering as well, where the traffic could be routed to any one of our global regions, depending on utilization. So we would try to like load balance traffic to kind of the least used region, or automatically away from a region that has some kind of issue, like in East US, if you're on global traffic, the global routing would try to avoid a region that's having issues or is down. So those are levels that the customer can choose. And if you choose data zone or global routing, some of that routing away is done automatically by the service. If the customer chooses regional routing, then if that region is down, then we give the control to the customer to deploy into 2 different regions or n different regions. And from the customer's application, they can then decide which region to address by which endpoint they send their request on, and then they can do the disaster recovery on their side. So there are several ways to do it, and several controls, whether you give that control to us to do or whether the customer wants to take control and do that themselves.
That's great. So you don't need to put all your eggs in one basket. If you're using Azure OpenAI for something really mission critical, then you want to make sure you're using multiple regions to span your ship across a big wave.
Correct.
Okay, that's great to understand. Callan,
Let me add more into that as well. As a good architecture, customers can have a secondary region to fail over the traffic. Again, API management also helps with AI gateway to have the failover and circuit breaker capabilities. If one region is returning more errors or responding as being down, then automatic failover can happen from the customers as well. So this is another example where customers using API management externally and internally can provide a good layering and a good failover.
That's great. I'm glad we provide lots of options for customers to be able to make sure that an issue in any one data center, any one region won't necessarily bring down the way they've implemented it. Thanks for adding that. As usual, I've saved my last question here for my co-host Sammy. Sammy runs our Azure Incident Communications team, and so just as we've heard about learnings from Azure OpenAI and from API Manager, I wanted to check in with Sammy to see, do we have any learnings from a comms perspective? Were we able to keep customers up to date during the outage? How did we do?
From a customer perspective, we initially started when this incident happened with a subscription list, and then we quickly moved to broader comms as we found out that this was impacting the entire region. We typically send these communications in one go, but this time we had to do it in batches as we understood the impact growth. So within 2 hours, we were communicating pretty much to all the people that we intended to. We did provide a workaround, which was talking about distributing workloads across other regions. But if customers hadn't configured that before, there was nothing much they could have done. You can't buy insurance after you've had the car accident, but customers had that configured. We did suggest to it. We didn't provide an ETA, which is, we like to provide an ETA whenever we can. But once we had a mitigation path that was determined and that was concrete, then we did provide ETAs on that. But before then, we couldn't provide anything because we just didn't know how it was progressing. We heard about all the levers that the engineering team were pulling, and we weren't sure which ones were going to turn into fruition. On analysis afterwards, it looks like we didn't communicate accurately. There may be some customers that were impacted that didn't get communications. We're still investigating that as well. It gets complicated, but from what we can see, we're okay, but we're still dotting some I's and crossing some T's there. During the mitigation, we spoke about the update being the rollback, and we spoke about the progress we were making, but from the kind of 2-hour mark to the 6-hour mark, the updates that we were providing weren't clear. One of the things we want to do is bring customers along in the journey. Say, hey, we tried this has failed. We know about this, we don't know about that. And about 6 hours into the outage of 9 hours, we were able to provide customers with a fuller, richer story about what was working, what wasn't working. This is what we've done. And then, we were able to kind of put in our ETA there. The mitigation statement was good that we put out, but there was a couple of conflicting kind of areas with the timelines. There's a little bit of fog of war there. We clarified this after with Chris and Gannon versus configuration changes and rollbacks, and we kind of got that finalized and tightened up in the PIR. But overall, it was bumpy. But one of the things, again, we can't control the mitigation time, but we can control the information that we provide. And so we really want to provide as much information, regardless of how relevant or irrelevant it may seem. If we can provide that information to customers during the event, that we can kind of exercise that partnership that we're so strongly looking for.
Yeah, that's a great point. And often, as Sammy and myself, when we work on call, when we're acting as communications managers, as the kind of the point between engineering teams that are working to fix the issue and the customers who are impacted by it, we know that we can be wrong, but we can't say nothing. And so really that push for transparency and to explain to customers exactly what's going on, exactly what we're working on is still very kind of top of mind here. So thanks for that summary. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.